Okay guys, so let's try this question. Here we have an arc, which I'll label here, which is hung by two threads of radius r. The arc is also of radius r. So let's label that. So first we need to find the center of mass of the arc. So we will do that by calculating the center of mass using integration. We will write dm, integral of dm, into the y distance. So let me just label the axis first. This will be the x-axis and this will be the y-axis. So now here the x-coordinate of the center of mass will definitely be 0, since the mass of the arc is distributed symmetrically about the x-axis, about the y-axis, not the x-axis. So we will need to find only the y-coordinate of the center of mass. So we will write integral of dm into the distance of the elemental mass from the x-axis. Let me first label the elemental mass. We will take the elemental mass in terms of theta. So suppose this is a very tiny piece of the arc, which is at theta, and this tiny angle will be d theta. So now dm will be nothing but r d theta into lambda. Let's find lambda first. Lambda is nothing but the mass per unit length of the arc. If we take the total mass as m and the circumference as equal to r into the angle of the arc, which is 30 plus 30 is 60. So let's write that as pi by 3. The lambda will be nothing but m divided by r pi by 3, which is equal to 3m by r pi. Let's put this into the integral. We will write this as the y coordinate of center of mass, which will be equal to a definite integral from minus pi by 6, 30 degrees on that side, to positive pi by 6, 30 degrees to the right, of lambda into r into d theta into the y distance, the distance of the element on the y-axis, which will be r into cos theta. So into r into cos theta. Now taking the constants outside, this will be equal to lambda into r square into integral of minus pi by 6 to pi by 6 of cos theta into d theta. Now if we calculate the integral of cos theta from minus pi by 6 to pi by 6, it comes out to be 1. So the y coordinate of center of mass will be equal to lambda into r square. We'll put lambda from here into this equation, and that will become 3r by pi. So the COM of the arc will become 0, here it's minus 3r by pi, but let's take the y-axis downwards as positive, so 3r by pi. The distance is what matters, that's all. So we have the COM. Now let's move on to finding the mass of the moment of inertia of the arc about the axis which it is rotating. So this arc is going to be in SHM about this axis, which I'm labeling in green. It's going to go to and fro this axis. So to calculate the moment of inertia of the arc, we will again apply integration. We will write integral of the same elemental mass again, lambda into d theta into r. This is dm, and we will multiply it by the perpendicular distance from the axis, which is this orange line again, in square. We'll need to square it, so that will be into r cos theta squared. Now this is derived from the formula of moment of inertia of an irregular object about an axis, which says that the moment of inertia is equal to the integral of elemental masses of the object into the distance from the axis squared. So this is what it comes from. So here we see that this is nothing but dm and this is nothing but x square. So let's write this in its complete form, which is equal to integral of minus pi by 6 to pi by 6 of lambda into r cube into cos square theta into d theta. Taking the constants outside, this will be equal to lambda into r cube to integral of minus pi by 6 to pi by 6 of cos square theta this time. So if we calculate the integral of cos square theta from minus pi by 6 to pi by 6, it comes out to be pi by 6 plus root 3 by 4. So the moment of inertia of arc will be equal to 3r by pi, wait, not 3r by pi, we'll just write it as lambda into r cube into pi by 6 plus root 3 by 4. Now the formula for time period of physical pendulum is given as 2 pi into root of I by mgl. Now here I is nothing but the moment of inertia of the object about the axis about which it is rotating, and L is nothing but perpendicular distance of the center of mass. Now in the diagram, if we look, the perpendicular distance of center of mass, which will be right about here, 3r by pi distance from the point of pivot. So the distance of center of mass will also be from here to here, which is 3r by pi. So now we will write this as 2 pi into root of, we have the value of moment of inertia from here. So let's put that in. That becomes lambda r cube into pi by 6 plus root 3 by 4 divided by mg into 3r by pi. Now if we replace lambda with the value which we calculated, which is 3m by r pi, let's replace this as 3m by r pi. We can cancel 3 pi and r also, so we'll get r square here, and this r will also get cancelled, so we will be left with only a single r. The pi will also get cancelled and 3 will also get cancelled, and so will the mass m. So now we are only left with the time period, a simple form, which is equal to 2 pi by r into pi by 6 plus root 3 by 4 divided by g. So this is the complete answer. Thank you.